Hello everyone, welcome to the IEEE MEMS Technical Community's Oral History Project. My name is Jack Judy and I'm a professor of electrical and computer engineering at the University of Florida and the director of the Nanoscience Institute of Medical and Engineering Technology. With us today is Dr. Hiroyuki Fujita, who is a professor of Tokyo City University and professor emeritus of the University of Tokyo in the Institute of Industrial Science. Dr. Fujita received his bachelor's, master's, and PhD degrees, all in electrical engineering, from the University of Tokyo in 1975, 77, and 1980, respectively. He is recognized as a world-leading researcher on the design, fabrication, and evaluation of micro and nano electromechanical systems, known of course as MEMS and NEMS, as well as their use in optical communication devices, tools for nanotechnology, and hybrid biomechanical nanosystems. Dr. Fujita, thank you for taking the time from your busy schedule to be with us today. Let's start our conversation with your early years. Can you tell us when and where you were born and share some memories from your early family life?
Okay. Well, I was born in Tokyo, 1952. That time, Japan is still under very middle of the development time. So I remember the road in front of my house is not paved yet, and sometimes even a horse, pulling some, cartridges, and they are dropping of them, etc. So it's the Tokyo has changed so much, but I still remember those days, and there are a lot of, trees and birds, insects, still a kind of natural flavor, around my house. And sometimes my family make our own party by making things by themselves. So I don't know the English word, but there are, can I say, stamped rice cookie, and usually, nowadays we purchase them, but they, how can I say, the steam the rice, make it on a very big like a big vessel, and stamp them together. And during my further stamping, my mother turns the rice in a couple of times, and they are kind of synchronizing very well. Otherwise, it's very dangerous. I still remember how this kind of synchronization of people can happen. And after that, my grandmother make me a fresh, sweet rice cake, and I enjoyed it very much. So that's a very early memory of myself.
I see. What was it like growing up in Tokyo in the 1950s, beyond what you've already said as a young child?
Well, that's I can have some can I say friends of the same year, and after the school we can go running around doing some baseball in space. There was space still, even in the middle of the Tokyo. Nowadays it is so much fully housed. But anyway, also we could go hunting of some insects, butterflies and dragonflies, so such kind of activity can be done. But also my mother was very anxious educating myself, and she put me into abacus, school. So I could do abacus with like 6, 7 digits, or even within my brain, I could add and subtract 4 digits numbers, like 10 or 20 of them immediately. So that was
Using abacus technology and strategies.
Yeah.
Fascinating, fascinating. Can you tell us more about your parents, and did you have any siblings?
Okay, yes, I have 2 senior sisters, 5 and 7 years older than myself. So they took care of me. For them, it's like it's a pet or a toy. Anyway, and my grandmother, father, grandmother, my parents, 7 of us lived together. So it's a kind of big family. And my father was the professional, army person, before the World War II. And when Japan lost the war, he need to change. And he was with the electrical kind of manufacturer, Okidenki, so-called. And he's kind of interested in giving me some practice making soldering. And that time it was vacuum tubes, not transistors. So I had 3 vacuum tube radio made by myself, but my soldering was so poor that it can I say make oscillation all the time. No. Then my father took that radio to his company, and the technicians in the company made it, very neatly. And after that, it worked perfect. Anyway, I felt a bit sorry about myself because I was so poor making, things. Well, unfortunately, my mother passed away when I was 10. So after that, my grandmother and the 2 senior sisters, took care of me very well.
I see. Please tell us about your early school years, primary and up through high school. What kind of student were you, and what were your favorite subjects?
Okay, so more or less, I'm a little bit lonely student, I guess, and I have a few friends, but not with everybody. And also, I like reading, so I read almost every day book. So I borrow a book from the library. I spent a couple of hours reading them, finish it. The next day I borrow another one. So I love reading novels. And also, my father bought me a couple of books, which he wanted me to read. And one of them is concerning Dr. Fabre. He's French. He was French, I should say. And he studied insects, very, very deeply by observation. And, I read a couple of volumes of his insect notes, and was pretty much fascinated of the scientific experiments and thoughts, how he analyzed the behavior of insect, such small, but they are pretty much intelligent in certain ways. And so I guess that's kind of a start of myself, can I say, interested in science and engineering.
And small things.
Yeah.
That's interesting.
That's true. Mm.
That is interesting. Now, you mentioned with some of your friends you play baseball. Are there any other things that you and your friends would do for fun?
Okay, so in junior high and high school, I played basketball. Oh. Jack, you are tall, but I'm like 6 feet. So as Japanese, I'm not too short, so I could work like a center. Okay, and I'm not so good at shooting, but for defense and rebound, I can take advantage of my height. So it was really, what can I say, fun, and I could strengthen myself by practicing and exercising. And of course, during that, I need to, well, as I said, my family is very much trying to educate me as much as possible. So they provided me the private teachers like English or mathematics. So that's how, can I say, I learned the basic, knowledge and conversation in English, also mathematics and some physics thoughts. Right.
So, of your early studies, are there any topics that you liked more than others?
Well, the mathematics is the most favorite of mine. And English I did, by the private teacher, so I could, do the English pretty well. I was a little bit confused with physics. So the teacher, high school teacher, was very good. However, there is I already learned about the differential equation, but his explanation, cannot be extended to that one because certain limitation of the knowledge, kind of say, rules are defined by the Ministry of Education. So I was somehow frustrated, why this crude explanation should be done, while the mathematic, analysis can be much simpler and much more straightforward. So that's how the high school age, I was a little bit, confused and not so much like physics.
I see. Now, you already mentioned some of your childhood activities, but did you have any other hobbies besides reading and basketball? Or there?
I started skiing the junior high. So, Japan has high mountains. The skiing is quite popular, winter season, the sports. So I did. Again, I'm not very good, but still enjoy. And winter scenery in mountainside, it's also fascinating.
Yes, very beautiful. Now, were there any early events or mentors that influenced your trajectory towards science and technology?
I see. I guess the reading books, that's almost all, what I learned before the undergraduate age.
And it sounds like your father with the electronics and you talked about your interest in nature and everything, so I can see that. So then you decided to study electrical engineering as an undergraduate student. How did you make that decision?
That's also a good question. At least initial first year and second year, the University of Tokyo have a general literature, education. And after that, we need to define ourselves into a specific, topic. And I have a very good friend of mine from the junior primary school age, and he's very much interested in biology. I also kind of interested in biology, maybe due to the insect books, but there are a very limited number of people who are allowed to go to that way. And I was need to choose a different, topic. And I really don't know why, can I say, electrical engineering. But okay, I can remember when I was the first year undergraduate, there is a small group seminar, okay, in which the Dr. Kaya, he is a pioneer of system dynamics simulation of the social events or energy system, etc. And I can I say it's 4 or 5 undergraduates, get together every week and learn his way of system computer simulation, of the system dynamics. And that age, the computer is so crude. We do very simple simulation. But I was really interested in such kind of application of computer simulation, understanding how society moves, and the system response is not simple. Even when you'd like to do something good, the system response may be completely reversed, right? So I initially wanted to get in Dr. Kaya's laboratory when I chose the electrical engineering department.
Now, you were born in Tokyo and raised in Tokyo, and you decided to go to the University of Tokyo. Did you consider any other options, or was it important for you to stay near family, or the school was the best for you?
Okay, yes. So back to the early age of mine, the primary school, every week we need to write an essay. And one of the title of the essay was what you would like to be in the future. So, and my title was I will be a researcher, scientific researcher, age of 10. And that case, I still remember the content. I would like to be Leonardo da Vinci, doing everything by myself. And somehow I'm not so much convinced with working in the industry, because the industry has a certain target to go. But somehow, even young, I'm very selfish. I would like to choose my own way by myself. So that was my kind of willing. And as a researcher, academic researcher, more or less you can choose what you like. So that's what I wanted, from the very beginning.
I see. Now, as an undergraduate student, did you get involved in research?
Yes, in the 4th year, we need to go to a certain laboratory doing a small thesis, okay? And that time, again, somehow, I chose the Professor Kono's laboratory. It is specialized in high voltage engineering. But the topic was computer simulation, that's a hook, of lightning stroke.
Oh.
Okay, and we could calculate the electrostatic field around the spark of the lightning. And by, it is guided by the most, strongest electrical field direction. So that's how they have certain fluctuation, but going to a tip of tower or etc., where the electrical field is concentrated. So, of course, the high voltage transmission line, should be damaged by the lightning stroke. So there are guarding, grounding wires to protect them. So I need to calculate, the field distribution, how it can avoid the direct strike of the lightning, etc. So that was the thesis for the undergraduate.
That's impressive. So now when you finished your bachelor's degree,
Yes.
I imagine some of your peers went and got a job, but you decided to go and get a master's. Why did you do that?
Well, as I explained from the beginning of my primary school, I would like to be an academic or researcher. And for that, I need to take the PhD. So I somehow be concentrated on pursuing the academic career from the beginning.
All right, so that guided you all the way to your PhD. Your master's project, what was that on?
That was an experimental project, and I continue on Professor Kono's laboratory, not going to the system dynamic laboratory, because the electrical discharge at high voltage, like 10 kV or 100 kV, is really beautiful. And you could change the gas concentration, or my work is lower temperature down to the liquid nitrogen temperature in the gas. And the things changes when you manipulate the parameters, and that's pretty pretty interesting. And there are stochastic analysis necessary. Of course, the modeling calculation is important, but you need to know the physics of gas discharge, how they separate into ions, etc. So somehow I continue the work on the electrical discharge at the low temperature.
Now, did you continue that into your doctoral thesis research, or did you do
Yes.
something else? Okay. Kept continuing that.
Mm.
Now, I guess I don't have to ask you the question of why you became a professor after finishing your PhD, because that was the place where you could do the research you wanted to do.
Yes.
And of course, you became a professor at the University of Tokyo, never having to leave Tokyo. Born,
Yeah.
raised, school, and now beginning your professorship. What was it like being an assistant professor at the University of Tokyo in the beginning?
Yes, was difficult, I should say. Well, the University of Tokyo, I started my own laboratory, even though I'm a very young, just a graduate from the PhD course, and I was at a loss what to do, and senior professors always asking me, what do you want to do, what you will do, etc. And they, of course, try to encourage me to looking for new directions. But finding new directions is not so easy. And I tried many different things, like non-destructive testing using acoustic emission. When the things cracks, there are ultrasonic sound emitted. And there are passive sensors, to detect such sounds and locate the initial point of the cracking by location, So, well, and after a few years, so there are senior professors who are a bit, anxious about my future, and they suggested me to go to United States, and that was in MIT. And again, the subject is very different, superconducting material, but the using acoustic emission technique to know how the magnet, make a clacking, at the liquid helium temperature. Everything is very brittle there, and there is a very strong electromagnetic field because magnetic field a few teslas, the current is a few hundreds of amps. So the Lorentz force, makes them, pulling apart. and what is the weakest point, should be determined. But you cannot put anything because liquid helium can evaporate, with a very small amount of energy input. So we need to do passive, measurement on the acoustic emission with the passive sensor, and the capability of locating the damage. So that's kind of a good match. So I did a few experiments over 2 years with the professor in MIT, the Dr. Iwasa. Okay.
I see. Now, tell us about the first time you discovered or thought about microtechnology and MEMS technology. What were the circumstances?
Yes, yeah, thank you for asking me. After coming back from United States, the liquid helium is so expensive in Japan. The United States, it is okay, right? But still expensive. But in Japan, it's very rare, and I don't have enough money to continue the work at the low temperature clocking, or superconducting study. And again, I looked for a couple of different subjects. And finally, there were two professors suggesting me that there are new topics emerging. It's so-called micro machines or micro actuators, and very small things made by semiconductor technology is driven by the force of electrostatic force. And I'm good at electrostatic, analysis. Of course, the size is quite different, but it doesn't matter, right? So I said, immediately, okay, I want to think about what is the best kind of mechanism which is driven by electrostatic force. And one of the professor is a semiconductor professor. So he kindly opened his clean room for me to get into the crude micromachining. So that's how I started the work, 1986.
Fascinating. Which was your first MEMS-related conference?
Yes.
And can you tell us about early impressions you had of the field and papers presented there?
Yes. Yeah. So I started 86, and another professor, he gave me a paper on which the Transducers 87 is in Tokyo. And he recommended to me, so it's a Sensors and Actuators conference, and why don't you submit a paper, to the conference? So I wrote a paper, abstract of my electrostatic microactuator, and very fortunately it was accepted as oral. And there were only 2 sessions for actuators. And I was with the second session, and that time Ronshan Fan, UC Berkeley, gave his talk on surface micromachined, released structures, and also Ken Gabriel gave the Bell Love MIT joint work for air turbine. You may remember that. And that time, I also did some presentation on the electrostatic actuator, which is a hybrid of small electrodes with a mechanical cylinder of 500 micrometers. So, but anyway, I was convinced at that time the combining the capability of micro micromachining and the force of electrostatic, and also some control and sensing capability of semiconductors. We could have a complete mechanical, controlled mechanical system on a chip. And that time, how can I say it? So I was so fascinated that my, hair, it's kind of
Standing up, you were very
yeah,
excited.
yeah.
I bet it was an exciting time
Right.
for
So
sure.
yeah, I could foresee clearly the future.
Great, yeah, no, that was an exciting time.
Mm.
So, can you identify individuals who played a significant mentorship role in your overall career?
Overall career, that's time to time there are good ones, but the two senior professors of Institute of Industrial Science, Dr. Ikoma and Dr. Harashima, he gave me good advice, occasionally, especially for starting micro, MEMS work. So that I owe them, pretty much.
I understand. Now, when you think back at your long research career, are there any particular projects that you think of most and are perhaps particularly proud of?
Okay. Well, the early stage, my actuator is only moving, and I would like to utilize some application. And I thought, photon doesn't have any mass, and micro actuators are so weak that they cannot handle any real mass. So, moving mirrors, in the chip, and bouncing, scanning the light beam is a good way to utilize micro actuators. And with a PhD student that time, Hiroshi Toshiyoshi, he's now the professor. We discussed and decided to do electromechanical microswitch. And he was again a very good researcher, dedicating himself in the clean room, making all the can I say detailed processing, and we had a paper on JMMs on the optical 2x2 bypass switch, and I guess it's the kind of beginning of optical MEMS field. So I'm very proud of doing something a little bit early, than others.
Absolutely. Now, that was looking back. Looking forward, are there any challenges or opportunities in the field of MEMS today that you're the most excited about being advanced by the field?
Okay, maybe just doing MEMS is kind of saturated. So I'm now attending Transducers 2023, and when I see the papers, somehow I might heard something similar in the previous years. So in a sense, it's a very matured field, and the introducing new topics or new technology together to be integrated with the MEMS idea. I guess it's a time for thinking about that. And nowadays, AI is a boom. IoT is a good application of MEMS, and edge computing is necessary, and also power supply energy harvesting, by MEMS is also crucial for IoT. So this is a way we need to go. So that's one direction. I also interested in biomems, and for the biomems, there are so many good devices so far, but bio is very specific to let's say diseases or some cells of some specific ones. So we need to do a more versatile, platform, doing things generally applicable for different experiments. And nowadays there are robotics laboratory, robotic automation of the bio laboratory. They introduce robots and they do all the mixing, etc. But microfluidics is much more suitable for automation. And if we can make a microfluidics environment, which can be generally used for many different biological, experiments. We could save space, energy, the samples, etc., and much quicker response is possible with microfluidics. So that's kind of a new way, revolutionizing the bio experiment. Could be a good way of utilization MEMS.
I see. Now, if you were a student today, which area of study or research topic do you think you would pursue?
Yeah, that's a very difficult question. I also interested in the astronomy. So, looking at stars and, yeah, and the physics, large physics, it's directly connected to the, なんだろう, quantum, science, right? And the very small elements, right? So that kind of scientific research may be interesting to me. And there are big sciences like space telescopes, and there are a lot of information technique to reconstruct the black hole image out of a very sparse data. So there are many opportunities. I might do something like that if I was a student.
I see. Thank you. Today, as you've retired, do you have any activities you like to do outside of engineering or any hobbies you have?
Okay. I have created the international network when I was at University of Tokyo. And my oldest collaboration with France is like just 28 years lasting still. And I want to write a book, how to create such collaboration, how to continue such collaboration, what is beneficial, out of such collaboration. So that's, I started writing, but just a few pages has finished. So it took me a while to do it.
That would be very valuable. Could you give us a little teaser? Are there any particular best practices you encountered, or how were you able to to maintain a successful research collaboration over so many years?
Yeah, I guess the complemental aspect, the French guys are good at modeling simulation. We are good at making things by experiments. And it is very complemental. So when we, collaborate, the Japanese do devices, the French do analysis and design, and comparing, those data, we can improve the devices much earlier, quicker, and better. So that's kind of a way. Not only the device development itself, but the Japanese and French researchers learn the way of doing everything, but initially by the team, but eventually they learn, both of them. So that's very important, and also the confidence and dedication, to the project, that is very important. You need to choose a good partner who is anxious of doing something. And of course, you have to devote yourself doing the same or more efforts. And both are confident. So if I do something for them, they will do something for me. So those kind of confidence relationship is a very important thing to continue.
I see. Makes sense. I'm curious, your area of expertise in some ways is, like you said, the construction of these microscale, nanoscale devices. And of course, to do that, you must have the right facilities and the right tools. Can you talk about the facilities that you've had to work with back in the early days and how they evolved? Did you simply just buy all new equipment, or did you make equipment? And I'm just curious about the realities, speaking as a person in the MEMS field who's worked in labs, and I'm curious what the experience was for you and your students in the laboratory.
Okay, actually I was from the high voltage engineering, nothing to do with semiconductor processing. So I not sure what I can make. So I depend on the external sources, purchasing equipments. And what I can do is writing good proposal to getting better funding and purchasing things and also showing the group activities like with France, etc. I could convince the director of the laboratory, investing something for me. So such kind of things we could make the laboratory for micromachining in a sense in line. And I allowed to use the younger generation, freely using my clean room. And I felt, or I feel, I owe to the high senior professors, guiding me to the micromachining, giving me some, budget to purchase the equipment. So this is for me to pay to the next, generation. So that's the idea, and that's how we operate the IIS clean room. So there is no real using fees, for that. And nowadays, I'm also get involved with a national network, opening the facilities of the many Japanese university like Tohoku or Kyoto, IIS, to be used by professors in all over Japan. And this is a 10-year project has just finished, and the next 10-year term. So I'm pretty interested in allowing the young researchers, getting access to state-of-the-art facility, and there are people who can train the students and professors for micromachining. So this is what I want to cultivate more and push it more.
Well, they're very lucky to have you as a champion. So Professor Fujita, thank you for taking the time to speak with us today and sharing stories about your impressive career.
Oh, thank you very much.